All right, page 69. Let's go over the homework. Can somebody read me what number 1 says? What does it say right here? Can you read that the correct way, Brittany?
Bananas are 59 cents a pound.
Perfect. Bananas are 59 cents a pound. I like that. You could say per pound. They asked, what is the constant proportionality? What is it? What is our K value? Yes, Brittany. 59?
No,
No. It would not be 59. It's close to that answer. Isaac?
59 cents.
You bet. 59 cents, which we would say is 0.59. So just use the decimal number there as your K value. Now, let's say I want to buy 25 pounds of bananas for the cross-country team because bananas are good for you. How would I find that price?
25.
Perfect. Very good. 25 times 0.59. That'll give you your total. Now, Target does something different. Do they charge by the pound at Target? No, they don't. Why not? What do they charge by? They do per banana. Why don't they charge by the pound? Wouldn't that be easier?
No.
Walmart charges by the pound. Hy-Vee charges by the pound. Family Fresh charges by the pound. Why don't they charge by the pound? They do have bananas, and my wife likes the bananas from Target the best.
They make more money. I don't know.
Maybe, maybe not. What they do not have is a scale when you check out. All the other stores, they weigh how many, whatever you got. Certain things you buy, it's by weight. Walmart, Hy-Vee, Family Fresh, their little scale, when you check out, their checkout has a scale there. Target does not. So they charge by the banana. Okay, they don't charge anything by the weight of it. Now, dry cleaning fee for 3 pair of pants is $18. What's the K value? Constant proportionality. Yes, Isaac? $6. Perfect. Now, here's the deal. If I ask what the K value is, you can just say 6. I like the label. It'd be $6 per pair, right? But if they just ask what it is, you just put 6. So now, how much would 11 pairs of pants be if I want to get them all dry cleaned? Yes?
$15.
How many?
No. 6. I messed up.
You're close. Yes?
66.
60. Very good. Sophie, $66. You take 6 times 11.
The reds are wrong.
Okay? So, yeah, you're fine. So, not too bad. Now, the last one. For every $5 that Micah saves, his parents give him $10. What do they do to his amount of money that he saves? They double it. What's the number that ties to double? 2. So, our K value would be equal to 2. Very good. So now, if Micah saved $150, how much would his parents give him according to this little plan? $300. So how much money does he totally have now? $450, right? $150 he saved plus $300 from his parents. It's very generous for them to do that. Now, in all of these, there's a dependent variable and an independent variable. For this last one, what depends on what? Does Micah's amount that he has depend on how much his parents give him? Or is the amount of money his parents give him dependent on how much he saves? First one or second one?
Second.
The second one, right? The amount they give him depends on how much he saved. If he didn't save any money, he gets $0 from it. If he saved $2, they would give him 4. These previous ones deal with dollars, and normally dollars depend on what you get, right? Dollars in the numerator divided by what you get. Okay, here you get a pound, here you get a pair of pants at the dry cleaner. Now, the next one, which you might see something like this on, say, an assessment. What you should do, you read through and you're like, I don't know what to do. Organize what information they give you, okay? So the 7th graders go to a life science field trip at the zoo. In 2010, the school paid $1,260 for 84 students. In 2011, the school paid $1,050 for 70 students. And in 2012, they paid $1,395 for 93 students. So they asked, is the price proportional each year? Well, how are you going to do that? Can you just look at it, say yes or no?
You can make a.
You bet. So organize it in a table, in a chart, and that's what I did here. Okay? And now the year really doesn't matter, but that helps me organize what we're doing here. So 84 students, costs $12.60. Now, again, does it make sense? The amount of money they pay depends on how many kids go. Does that make sense?
Yeah.
Okay. This next assessment will rely heavily on you understanding the concept of dependent and independent, which really the book has not done a lot, but I think it's important for you, and I think it helps you get the understanding of the question a little bit better. So your cost depends on students, and we just wrote down what each was for each of those years. Now, to find the K value, what are we going to do? Take your Y value divided by X. Let's go these two rows right here. These two rows, you're going to do the first set. Take 1260 divided by 84. Did you do it already?
Yeah.
Oh, you already did it. What'd you get every time?
15.
15. Every time was 15. What does that mean?
It's proportional.
It's proportional. The K equals 15. So is it? We would say yes. Why or why not? Because K equals 15. Now, what that K counts proportionality, what does that mean in this situation? What does that 15 mean? Yes, Brittany.
$15 per student.
Perfect. $15 per student. Every student that goes, they got to pay $15. Now, they asked an extension type question. What would the school have to pay if 120 students went? So now we know 120 students. What are we going to do to 120, Brittany?
We're going to times it by 15.
Perfect. Multiply by 15. So go to your calculator, take 120 times 15. That should be your answer. Hopefully you already did this. But now they say the last one. What if we know they pay $14.25? Sometimes, like in our school board meetings, they have an agenda and they pass whatever. And they say, well, $1,425 was given to the 7th graders to go on their field trip. Could we figure out how many 7th graders went on the field trip? Yes, Brittany, what would we do if we're going back the other way? Divide by 15. And what is $14.25 divided by 15? Someone other than Brittany, because she knows everything on this one. JC. 95. Do you agree with that? Hopefully y'all did that. Is that complicated stuff? No, that's kind of stuff you're going to need to know on the test. Okay?
When's the next test?
When is the next test? That's a great question. Next Thursday for this year of 2020. Next year might be different. All right. Next page. Okay? So we're starting lesson 8. It's a review. It's tying in some stuff we kind of already know. So we're not some new things. So they say proportional relationships have a constant ratio or unit rate. What is another name we have for both of those? Proportional relationships have a what?
K.
A K value. What is the name of the K value? You bet. All these are synonymous. Okay? All those are synonymous. That means they're the same. I can talk about constant ratio. I can talk about a unit rate. I can talk about constant proportionality. Now, this constant ratio we can write like this. Now, what is another name for that constant ratio or unit rate? We just said constant proportionality. So we know y over x is the same as k. That makes sense? So now we have a new version, so to speak, and we've kind of looked at it a little bit before. Now this is important information. Now, what is an equation that we used before that involved all these letters? Who remembers that equation that we used before? A little formula. Yes, ma'am. Dirt was one, but I don't see a D, R, or a T, but it was like it. What was the one that used these letters? That was the distance formula, FYI. Distance formula looked like this one. What was it involving these 3 letters? No, you're changing them. What was the original one? That has these 3 letters. Yes, Brittany? There it is. You guys not remember that? Did we not talk? Did I forget to talk about this one?
Yes.
Oh, I'm so sorry. Go back and look at your notes. I have videotaped that you were lying. So here's the deal. This was the original one. Okay? Now, you're going to be solving equations for the rest of your mathematical career. And it's always the same. They're going to get more and more complicated, but there's something that's always the same with every equation you're ever going to look at. You're going to try, the goal is to get the variable by itself. Okay? Now, I see 3 variables. In this case, we're going to focus on this guy. We got to get that variable by itself. So what I'm going to do, I'm going to rewrite it, y equal, I almost did the trick. Y equals kx. I need to get that k by itself. Well, what is with the K and X? What am I doing with those two things? Am I adding, subtracting? I'm multiplying. What's the opposite of multiplying? Divide. So in order to get the K by itself, I'm going to divide this side by X. And in math, it is so important to be equal. I need to do one thing. If I do it to one thing, I got to do it to everything. And if I do something on the right side, I have to do the exact same thing on the left side. So if I divide the right side by X, I got to divide the left side by X. Okay? Now, let's step away from variables. What's 7 divided by 7? What do you get? 1. What is 99 divided by 99? 1. On the test that we just took, some people got 25 out of 25. That's 25 divided by 25. That is a 100%, right? So you got all of them right. Here's the deal. When I divide those out, I get 1. What is 1 multiplied by anything? What is the answer always going to be? 1 times 7 is 1? It's whatever the number was. Yeah, so here's the deal. The K multiplied by 1 just stays K. I'm going to drop down the equal sign. The K is going to be by itself. And now I don't know what the values are, so I just leave it. Isn't that what we saw just above here a little second ago? K equals Y divided by X. Okay? So now here's the cool thing. What we can do, if I give you what this value is, the constant of proportionality, if I say K equals, say, 5/4, can you tell me what Y equals? Can you tell me what X equals? Yeah. Y is going to be the top number, and that's 5. X is the bottom number, that's 4. So now I know a coordinate pair. How can we write this using the parentheses and the coordinate pair? Which one goes first? 5 or 4? Why 4? Why is it 4? That's correct. It's always X, comma, Y. That's our coordinate pair. Always X, always Y. Okay? So my X is 4, my Y is 5. So that means I go over 4, up 5 on the graph. That's one point. Can I come up with another point? Is there another point I can come up based on this information? Brittany, what would another one be? That's the same one as this. Nope, I didn't want a different way to write it. What's another point? So on the graph, I go over 4, up 5. There's one point. Where's another point that's going to be on that straight line? Tyler?
8 and 10.
Perfect. You see that? 8, 10, that's all it is. Another one could be 12, and then what? What do I do to 4 to get to 12? Times 3, so I got to take 5 times 3, I get 15. So now, just from this K value, the constant of proportionality, I can come up with actual points on the graph. I could graph it. I could verify whether or not it was a proportional relationship. Okay? All right, that's some stuff we're going to be looking at here over the next couple days. Let's go to the next page. Now, similar to yesterday, I love the problem yesterday, the second one. You need what? Something like that. When you go home and tell your mom, okay, I want to bring cookies for everyone on our team. Let's say there's 110 kids on our team, and you want to bring 3 cookies for each kid. How many cookies would you need? 110 kids, 3 cookies each. 330 cookies. And you say, I need them when? Tomorrow, Mom. Will your mom or dad be happy if they heard that? No. My parents were very, my kids were like that. I probably was like that with my parents too. I spring stuff on. How long have you known about this? Well, about a week. Why'd you tell me that? Okay. So this one is another kind of real world example. It's, do we have enough gas to make it to the gas station? Okay. Now, your mother has just accelerated onto the interstate beginning a long road trip, and you notice that the low fuel light is on, indicating that there's a half a gallon left in the gas tank. Now, here's the deal. Back in the old days, cars did not tell you if you were low on fuel. You either had fuel and you watched it go down and down, or you were out of fuel. You had to pay attention to it. Every time you got in the car, that was one thing you checked. Do I have enough fuel? And you'd fill up. You'd learn the hard way if you ran out of gas. Now cars are smarter. We have a 2009 Suburban, and a light comes on and dings at you if you are low on fuel. Ours warns us when there's about 3 gallons left. And at least then you have a little bit of room to get to a gas station, some miles to go. And it tells us you have about 50 miles left before you're empty. Okay? This one, you only have half a gallon when it came on and reminded you. I remember when I was a kid, we were in South Dakota on Interstate 90. What's our interstate right here? 80 down in Kansas. Do you know what that interstate's called? 70. It counts up. Okay. So anyway, we're on I-90. Not many gas stations out there, and we run out of fuel just as we're exiting the interstate, and we coast into a gas station. And luckily, we're able to make it without pushing too much. But again, now cars kind of warn you, so pay attention to that. Now, your mother keeps a log or journal where she records the mileage and the number of gallons purchased each time she fills up the tank. Now, do I do that when I go fill up? No, I don't. Did my dad do that? Yeah, and I don't know if he still does it, but I remember him, he had a little notebook in his glove compartment, and he would write out, every time we bought gas, he'd write down how much it was, he'd write how many gallons he got, and then we'd figure out how many miles per gallon was he getting, okay? Now, use the information in the table below to determine whether you will make it to the gas station before the gas runs out. You know that if you can determine the amount of gas that her car consumes in a particular number of miles, then you can determine whether or not you can make it to the next gas station. So what we need to do is figure out that K value of what's going on. Now, before we do that, what is the Y, what is the X? What's the name of the Y variable again? Dependent. The Y depends on what the X is. In this case, do the gallons you have depend on how many miles you drive, or do the miles you're able to drive depend on how many gallons you have? The miles depend on the gallons. So this is your Y, this is your X. Okay? That makes sense? So let's go these two rows. That's what we're going to do. These two rows do 224 divided by 8. The middle row, you're going to do 280 divided by 10. You probably do it in your head. These two rows do 112 divided by 4. Normally, you would check all three, but let's divide and conquer. What do you get when you plug your values into the calculator? You got 28. Middle row, what'd you get? You don't need a calculator. What's 280 divided by 10? Zeros cancel out. What's 28 divided by 1? 28. And then the last one, what's 112 divided by 4? So we know K equals 28. Okay, from that, can we draw or write a formula? Can we do a formula now? And instead of Y's and X's, can we use variables that tie to our situation? So our Y is like miles driven. Let's do M, which is like Y, equals, what's my K value? 28. Now, instead of X, we're going to talk about gallons. What would be a good variable to represent that? G. So the miles I can drive depend on, well, what my gas mileage is and how many gallons of gas I have. All right. What does the constant proportion of, what does that 28 mean in this situation? You bet. The car gets, or let's go, goes 28 miles for every gallon of gasoline, but we need to stop. We know we're talking about gas. Does that make sense? What's the equation? Oh, we already did the equation. We're ahead of the game. What's the equation? You can draw an arrow like that. Here. Oh, yeah, there's the one. Now, knowing that there's a half a gallon left in the gas tank when the light came on, assuming that you saw it right away, what if you like, oh, geez, I don't even know how far we've gone. The light must have been on a while. I didn't even notice it. Is that a good thing? No. The clock is ticking when that light comes on. So now, will she make it to the nearest gas station? Yes or no?
No.
No. Why do you say no?
Because for every gallon is 28 miles, and nearest one is for 25, 26.
26.
So she only has half a gallon.
Perfect. And so what's half of 28?
14.
Half of 28 is 14. She can only go 14 miles. Abraham's explanation was perfect, but very wordy. We could boil it down. She only has half a tank of gas. Half a tank of gas will get her half of the 28 miles per gallon, so she can only go 14 miles, but she needs to go 26. So that's a not the good situation. Somebody third period said, well, maybe she has AAA, which AAA you can pay a good amount of money every month. And if you break down, you have a flat tire, they'll come out, change it for free, or pay somebody to change it for free. Or if you're out of gas, somebody can come out and give you gas, they'll pay them. My in-laws have that, and they're older, and that's good in case they're out on the interstate and they break down, they don't want to change a tire. For me, though, I make sure I have enough gas, and hopefully I don't break down, because I'm on my own if I do. Now, using the equation found in part B, determine how far your mother can travel on 18 gallons of gas. Now, they say solve problem 2 ways. Really, I think these are so similar, we're just going to do it the one way. What was our formula again? M equals 28G. What are they asking for? How far, which is the miles, equals, what was our K value? 28. What was the gallon amount that we have? 18. So we take G would be 18. Well, how do I get, the variable's already by itself. Boom. So I go to my calculator and I take 28 times 18. Everybody's doing it. 28 times 18 in your calculator is 504. 504 what? Dollars? Cars? Miles. All right, make sure you label. She can go 504 miles. Now, assuming that's round trip, how far could they drive before they need to come back? So they have enough gas to get back. What's the furthest they could drive? Yeah, cut it in half. Divide it by 2. What's 500 cut in half? What's 4 cut in half? 252. But now, if you drove 252 miles away, are you going to make it back?
Yeah.
Maybe not. Maybe not. You would just be coasting in on fumes. And if you're driving uphill, maybe into the mountains, you take more gas on the way there. On the way back, maybe less gas. But I would maybe say you could go no farther than maybe 450 miles away. So you have a little extra. Now, using that K value that we found in part B, determine how many gallons. Now we need to know gallons you could travel if you wanted to go 750 miles. So they're like, we want to go so far away. The round trip is 750 miles. How many gallons do I need? Well, what do we know in this case? What variable do we know? The miles is 750. So I write 750 equals, what's my K value? 28 times what? G, we don't know what it is. Okay? Now, here's the deal. You've done a little bit of solving equations, I think. And here's the deal. I said it before. The goal when solving equations is going to be the same for the rest of your math careers. High school, college, it's going to get more complicated, but the goal is always the same. The goal is to get the variable by itself. What's the goal in solving equations? Get the variable by itself. Nice and loud. What's the goal in solving equations?
Get the variable by itself.
Very good. You all said get the variable by itself. Here's the deal. We have a variable there. Is it by itself? No.
Yeah.
Now, what I do is I put in a line here. I call this line an elevator. What do elevators do? They go up and down, right? Here's the deal. This elevator will take the equal sign down, and it's going to go in a straight line here, okay? Now, before we move the equal sign, I need to get this thing alone. Well, what am I doing to the variable G? I'm multiplying by 28. Do you agree with that? What am I doing to the variable G? Multiplying by 28. What's the opposite of multiplying by 28? Divide by 28. Before I said property of equality is very important math. If I do something on the right side, the left side says, what about me? You got to do the exact same thing. So I got to take the left side divided by 28. Now notice, I didn't use the dot line symbol for dividing. That can be misconstrued for other things. It can be overlooked. If your dots are too small, it looks like subtracting. If your dots are too big, it might look like an adding symbol, okay? So I use a horizontal line when I talk about dividing. What do we say before? 28 divided by 28 would be what? 1. What's 1 times G? G. I drop down the equal sign now that I have the G there. I don't do an equal sign when I'm doing my work. I drop down my equal sign. Now, go to your calculator. What is 750 divided by 28? 750 divided by 28. Somebody on this side. Does it fill up your calculator?
Yes.
Yes. It fills up your calculator. So I say round to the nearest 10. So it's 26.78, is that correct? The 7 asks the 8, what should I do? Should I stay the same or go up? And the 8 says, well, I'm over half, so go up. So this would be 26.8, is that correct? 26.8 what?
Miles.
Is it miles?
No.
No, we're finding G, so that'd be gallons. So 26.8 gallons would be needed to go 750 miles. That make sense?
Mm-hmm.
All right, next one. Andrea is a street artist in New Orleans. She draws caricatures. Those are like funny cartoon characters of people. They look like them, but they draw them. It takes her a little bit to draw them. People have the portrait drawn and then come back later to pick it up from her. What I would suggest if you do this, don't pay her till you actually get the portrait. When I was in Greece, we had somebody take our picture in front of this big museum type thing. It was cool. Pay me like 20,000 drachmas at the time. So we paid him. He said, I'll be back here at 3 o'clock. I'll give you a picture. He came back at 3 o'clock. Guess what? Nowhere to be found. The guy was gone. He ripped us off. Took our money. So don't pay until you actually get your stuff. So now the graph below shows a relationship. This is the x-axis. This is the y-axis. That also tells us this is our x value. This is our y value. Okay? Now, we want to write several ordered pairs from the graph. Remember, ordered pairs are like this, x, comma, y. Okay? And when we graph them, it looks like this. It's left or right movement, followed by up or down movement. All these problems are going to go to the right and then up. Okay? So now, where are some points on this line that appears to be straight and going through 0, which means it is proportional? Where does it intersect nicely? Right there. What would that coordinate be? Over 2, up 3. So that's 1 point. What's another one? Look at this line. Where does it intersect nicely? Looks like right there. What is that? Over 4, up 6. Is there another one?
Yeah.
Looks like there, which means over 6, up 9. Now, what do these points mean? The first number is our x. What does it represent? Time in hours. So this represents it took her 2 hours to do what? To do 3 portraits. Okay. Next, 4, 6. What does this mean? 4 means time. So it took her 4 hours to do 6 portraits. What about the last one? To do 9 portraits, how long will it take?
A long time.
Nope. 9 portraits would take her 6 hours.
Not too long.
Okay. That's not that long. And if she charges like $20 a portrait, she just made $180 in 6 hours. Is that pretty good?
Amazing.
Not too shabby. Okay? Now, what are several equations? What we could do is go, what is our k value in all of these? What is our y divided by x? What's y? What's our y? All of these reduced down to the same one. Y would be 3 over x is 2. So our formula could be this. The portrait she can draw equals, well, 3/2 times the amount of time she has. All right. So if she had 1 hour, how many portraits could she draw in 1 hour? Well, what's another name for 3/2?
1.5.
1.5. Okay? So if you took 1.5 times the amount of time she had, that's how many portraits she could pick out. Okay? All right. Next page. All that really tells us is now we have a new way to talk about k. It's y divided by x. I'd write that down again. Okay? We have a proportional relationship. We have an ordered pair, set of ordered pairs that satisfy that equation. K is a positive constant, although later on we're going to look at negative ones. But the ones we're all looking at is positive number. It's the same every time. We know we call it that. We can also then express it using X and Y, relationship between your X and your Y. Okay? That make sense? That formula, you gotta have that tight in your brain. For your homework, we're gonna jump to, after you read over the homework helper, look over the homework helper. Make it make sense to you. Take the time. It might take 3 or 4 or 5 minutes to do it. It'll help you understand these a little bit better. Do 1 through 5, not 4. Okay? Make sure you're paying attention to what they ask. Number 5, you might need to organize your information kind of like you did before in a table. They give you some room down here. You can organize that. 1 through 5, not 4, due tomorrow.